here, back at the ejector system. I did a little video yesterday demonstrating, let's see, where is it? Get them both out here. My two new primary, well, excuse me, my new primary nozzle. I've since made another one. Let's see here. The one I actually built is in the system right now, but I showed it in the video yesterday. It's actually similar to this, other than it doesn't have that capillary tubing tip. I just made this one this morning. I am happy to say that the Delrin sleeves that I may have mentioned before work just fine in order to seal the compression fitting. This is just has a regular brass ferrule. It's a little bit goofy. It's a strange one I got at Home Depot, but that sucker doesn't move. So installing this pretty well sets it in one spot. You can't adjust it. But that one is designed to just spit just barely right across the horizon into the throat of the ejector. Now, what I have in there right now is a nozzle that I made. There's no capillary tubing in that nozzle. Like I said in the video yesterday, I reduced the diameter of a piece of 1/4-inch tubing down to about 20 gauge, 22 gauge maybe, very, very small, and then brazed that into a piece of 3/8 pipe, which is this pipe here, 1/4-inch, going down through the 3/8. Now the idea there was to try to, a little demonstration here. Now, you can see with the original primary motive nozzle, it tapers somewhat gradually. Now, my concern was that even though it just spits just right across the horizon there into the throat, my concern was that the reason I used the 3/8 was to reduce the annulus inside the 1/2-inch pipe, because you have refrigerant being sucked in and going through that annular space, and then being pulled into the ejector throat. Now, because it tapers so gradually, I was concerned that since the cross-sectional area increases, that the velocity of that refrigerant coming down through the annular space was actually going to decrease slightly right before it went through. And so I thought, well, I'm going to screw around a little bit before I get my parts for my next modification. I'm going to screw around with some different shapes and styles. Now, I went with a much smaller orifice as well, which probably wasn't really a good idea, because it's harder to tell exactly what is, if there's an improvement or what exactly is going on. But yeah, what the hell, I did it anyway. I thought it'd be fun. Hoping that, with that smaller orifice, that the velocity would increase across the tip of the primary motive nozzle, and if you have higher velocity, lower pressure, it would actually draw refrigerant through it faster and give up more kinetic energy to that refrigerant being sucked from the evaporator, thereby compressing it once it re-expands across the divergent nozzle. Now, what I've found is somewhat the opposite. Not the velocity part. I don't know what effect that has had, other than I just generally have lower pressures on my low side now. I've actually found that I've run this one in 3 different positions. It's just the same cap tubing as the original primary motive nozzle. You can see it puts a little impression in there, but I'm still able to move the Delrin sleeve and retighten. Now, I've run this one almost bottomed out, backed off a little bit, backed off a whole lot. Not a huge difference. Almost completely buried down into the throat of the nozzle here. It doesn't really work much at all. Backed off the most, I'd say it works the best. And the same with this one here, which is the one that doesn't have cap tubing in it. I've run it in 2 different positions, backed off a little bit and backed off a whole lot. It's backed off a whole lot right now. I get about 5 or 6 psi compression out of it. I think what I'm going to end up doing is actually make another one similar to this. I'm going to fool around with some different sizes of cap tubing on the tip. I'm going to fool around with extending and making the 1/4 inch length a little bit longer. And I might even try a piece that's almost entirely 1/4 inch. Maybe this reduction in annular space wasn't really a good idea. I don't know. I thought I was onto something there. But so in the future, I'm going to try several different styles and continue on with the Delrin sleeve because they don't seem to leak, allowing me to adjust and probably reuse some of the components too if I make a dud. You know, I don't want to make too many more changes too quickly, but having a whole pile of these things around, different styles that I can adjust the depth on, it's a hell of a lot of fun. In the last 24 hours, I have shut her down there. In the last 24 hours, I've shut this thing down and pulled the charge, changed out or adjusted the depth on the primary motive nozzle. I've probably done that about 5 times, 4 or 5, yeah, at least 5 times now. Doesn't take very long. I can do the whole operation in about 20 minutes. Obviously, I'm not pulling a very long vacuum, but meh, that's okay. I mean, I have run a deep vacuum on this thing for a lengthy period of time just to get a lot of moisture out of it. But yeah, I found it's fairly easy to change this thing out, which is what I wanted. And generally what I do, I keep 2 tanks. There's a tank down there for junk refrigerant, and this is a tank for fresh refrigerant. This tank, I actually emptied it, evacuated it for a period of time, and then charged it with fresh propane directly off of about a 1,000-gallon tank or something, whatever we have at work. Hoping that maybe I had some trapped gases, non-condensables or something in there. I haven't really noticed much difference, but I need to do a kind of a pressure temperature analysis on there with the setup I have. But whenever I recover, say the propane that's in this, I'm not going to put it back in the tank I just got it out of. Put it in that tank, and it's burnt to squash. That is, of course, for the refrigerator and the water heater, cooking, whatever, and just keep the fresh stuff going in. So until I get some parts for the accumulator tank, I'm going to get some sight glass plugs I have ordered that'll braze some threaded adapters to the 1-inch separator columns, so I can actually thread those sight glasses in there, and that'll give me a view window of what's going on inside. The extended sight view glass is okay. If I insulated some of the brass and copper here a little better, I wouldn't get so many bubbles and stuff going up through. But I really want to be able to see what's going on inside. And I also not just want to see the liquid level, I want to see the quality of the refrigerant coming into the column, and how that changes and stuff. So as far as the empirical analysis of this, it really helps to have some sight glasses. As for this valve here is the gate valve, and this feeds liquid off the bottom of the separator column. So this is refrigerant, high side refrigerant going through the ejector, picking up refrigerant off the evaporator, going through the ejector, and then spitting liquid and vapor down here into this column, which the liquid settles out, and the vapor gets drawn back to the compressor. Any liquid that comes off the bottom goes through the gate valve, goes through the entire length of the evaporator, and then back up, and get pulled back through the compressor. So we have 2 loops essentially going on here. The gate valve was a good idea at first. Gives me the opportunity to open it fully open, wide open, and observe how that changes the system, and then of course crank it down. It's the cranking down that a little more difficult. There's too much range there. I'd like something with a little more control, so that'll get like a needle valve, and eventually a TXV for a later idea. As far as going with the dry evaporator, it was easier when I first started. I wanted to get the thing going. In some ways I'm glad I did it. I learned a lot from having a dry type evaporator, but the only way to get a good pressure difference between these two is to really close that down significantly, which only admits enough refrigerant through the coil to probably bottom 2 or 3 coils, and then the rest of it's just superheat. It's actually fine. You don't get a significant amount of cooling. You're not picking up a lot of heat because a lot of it's being done as sensible heat. it's probably not that detrimental to the system, because in the course of circulating back through the ejector, that superheated vapor gets resaturated and brought back down in temperature whenever it enters a column, and the vapor that goes back to the compressor is saturated. So I'm not superheating the hell out of the suction vapor, so that's kind of neat. But it's not an effective way to pick up heat. I want saturated vapor. And I think a lot of the work that the ejector is doing, whenever I do supply the evaporator with sufficient liquid, a lot of that work is going into pumping the liquid through. There's a pressure drop across that, and I kind of lose that pressure difference, or at least the work that I'd like to be doing with the ejector. I don't need the ejector to pump refrigerant through it. If I wanted that, I would just forget the ejector and just put a TXV in or cap tube and just, you know, build a standard system. But my original thought with this was, I'm going to do some work and pump refrigerant through it. Well, I'm shying away from that. There's probably something I could continue on with it, but I'm really curious to see what will happen if I go to kind of what's more generally goes with an ejector system, which is an accumulator tank. So this would end up being a flooded system, flooded coil. The metering device would blow into a column similar to this separator column, and the liquid level be maintained manually at first by me. Liquid settle on the bottom could circulate through the coil, and heat is picked up, causes vapor, causes ebullition. Liquid and vapor is carried off, overflows, and goes back into the separator tank, where liquid can continue doing the cooling work, and then vapor can be drawn off and go to the ejector, going back to the medium pressure column there. There's a few other things I want to mess around with there, but until I get the parts, I can't do a whole lot else, other than if I want to continue making primary motive nozzles. So probably spend the time until I get those parts and get that built, doing some research, reading, and writing, get caught up on the old blog. So thanks for watching, and you have a lovely day.